Welcome to the Point of View series by Harbinger Systems. The Point of View series aims at addressing the most frequently asked questions about HR tech, and this, of course, will be backed by Harbinger's own research and experience in this area. My name is Jomi John, and today's point of view would be optimizing cloud costs for deployment, especially for AI solutions. Joining me today would be Mahesh Kumar Kharade, who would be my co host. And along with him, we would also have our expert consultant, Suhas Joshi, who would be taking us through his point of view on this topic. Welcome, Mahesh.
Thanks, Jomi. Really happy to be part of this session today.
Great, and that's especially important because, this point of view is going to be very important for you if rising cloud costs are something that is bothering you. As per Deloitte's global predictions for the next few years, companies will accelerate their usage of cloud, especially in the area of artificial intelligence, software, and services. This makes today's topic even more relevant. Mahesh, don't you think that we have been speaking to many of such companies in the last 3 years?
Yes, Jomi, I think you're spot on. We witness this trend every day at Harbinger while working on different projects or while talking to different teams internally and even while talking to different customers. In fact, what I have noticed in all these discussions, a pattern which is about any company who is trying to do something with AI, I think they are trying to adopt it using a combination where they're using AI capabilities through a cloud-based enterprise software services and a custom AI component, which is like sort of built and deployed into the cloud using different cloud services. And what I hear a lot from our teams is that with more and more choices available, I think it is bringing certain challenges for the selection as well. And this selection approach goes beyond functionalities offered by these AI services. And I think that's why to talk about this, I would like to invite Suhas Joshi, who has architected and worked on many such custom AI implementations in the past. He has over 3 decades of experience and he's so passionate about solving different engineering problems. And also, he has written an informational blog post on how to optimize cloud costs for AI solutions, which will be anyway sharing after the POV session for the audience. Welcome, Suhas.
Thanks, Mahesh. 30 and 30 is a nice combination. Harvinger completes 30. I have completed more than 30 years in the career. So we have gone along well all through this period. Happy
Yes.
to be.
Yes, good to have you, Suhas. And Suhas, like nowadays, we hear a lot about combining these ready AI services and custom models for better and quicker AI implementations. Can you walk us through an implementation scenario where you have used this kind of approach recently?
Yeah, sure. So let's look at recommending appropriate jobs to a candidate as a problem. So candidate's resume, which contains all the information about the skills, certifications, experiences in different domains, and current and past roles performed, current location, etc. Whereas a job description contains information about the nature of work to be done, expected role, mandatory and desired skills, and all that. So there are various factors in these two different documents. So one has to gather these characteristics from the text of the job profile and job description. So these are NLP problems. And there are ready solutions like resume parsers, which can extract this information. Or you also have domain-specific solutions. So for HR Tech domain, you can have solutions like Google Cloud Talent Solution. Now that also helps in matching the candidate role and trying to find jobs. So this is where the ready stuff is useful.
Mhm.
But these solutions do not necessarily satisfy all requirements in assessing the suitability because that depends on the real business problem. So, for example, if assessing experience of work and its sort of relevance based on job experience that is quoted in the description, now this becomes a different kind of NLP problem to solve. And that's where uh, looking at custom AI solutions comes into picture. And then on top of that, you add some heuristics in terms of finding relevance and all that. That's where the custom parts come into picture. And that's how the combination becomes important.
Excellent, Swas. I think combining these approaches makes so much sense now with this kind of an explanation, looking at the real problem, right? And so, as you were talking about these custom AI components, I had a thought about cost aspect because I mean it's always good to have the such options, but there's a cost play as well, right? So, with the kind of cloud pricing options available nowadays, how does it apply to these custom AI components now?
Yeah, so primarily all resources are available in pay-per-use model, and after the system matures, companies can start looking at reserved instance and those kind of things to sort of optimize costs. But initially, it always begins with pay-per-use model of provisioning resources, and that very quick provisioning of resources sometimes also results in over provisioning because it is done at the time of development stage where all the future aspects are not necessarily taken into account. And then additional such resources get added as we move from development to stage to test to production. And that's where sometimes you start noticing it a little different. Although there are calculators available, but their use demands forecasting of load, which is again always not done. So that's the kind of scenario with this modeling.
And I think that's so true. In a lot of places, I have used cloud calculators when estimating cloud costs for some of our customers. And you're right. There's always a mismatch when when the setup actually goes for production. Why? What do you think causes this change?
Yes, so one is the pay-per-use model of this compute infra. You sort of pay as long as it is used. But the usage doesn't mean that actually the requests are getting processed. Usage just means that it is active. And that's where the idle time also you start paying for that. And if you don't have a eye on that, and if you can't shut down the resources in a pre-planned manner, you still end up paying more costs than what you actually need. And the other aspect of this is that when you sort of use these custom modules for AI, with availability of deep learning algorithms, some of those solutions could use deep learning techniques as well. And those get deployed on GPU infrastructure. Now, that essentially is much more expensive than the normal CPU infrastructure. And that's where you sort of have additional component and the idle part and complete resource utilization, whether it is happening or not, comes into picture, and all that eventually gets noticed as sort of escalation of costs when we move to production.
Okay. Okay. I think so. As I'm seeing an interesting common node here when it comes to the conventional web applications that I use to optimize the cost for, and when I look at the AI applications, I think there is this underutilization or utilization versus provisioning is a common aspect that I'm seeing, and I have used or probably relied heavily on the audits to kind of find out such gaps. Now, does the same apply to these AI solutions too, or like how exactly you do these optimizations?
Okay. So Mahesh, I think audits do bring out areas that need attention definitely, but it is at a certain point of time you take that sample and start making decisions. Now, what we have done is we have applied a combination of performance analysis and capacity planning aspects and those areas to apply this to cost optimization problem. We have done this successfully for our own AI-based product, Quillians, and helped optimize costs for some of the customers also. So let me explain how we sort of use that with a slide. Just give me a moment and I will share my screen with the slide. So I hope you can see my screen.
Yes.
Okay, so I'll just first give you a quick glance of the steps in the methodology. So we gather the deployment architecture details, so which sort of nails down which infrastructure components are deployed, which services are deployed, and we understand the details of that so that we know which logical components sit on which servers. Then we look at cost details, and we are able to then map. Okay, where is the extra cost? What kind of components are there? Now that essentially is like a background work that we start with. Then we gather usage data. Now, if the system is already running, we can get its current state just by using cloud tools, which shows the metrics in terms of resource usage and what kind of load was there on the system. So that could be one way to sort of look at that. Then we analyze that data, correlate the requests and resource usage, and do analysis on time-based usage, analysis on resource underutilization or overutilization. And all of that gets combined to sort of discover cost optimization opportunities. So now, to just get a feel for how we go about this, so let's look at some charts here. Okay, so you see chart one. So let's assume that this was during the view of whatever is already deployed in production. Now, if you see this resource utilization, so here it shows that, okay, this is about 20-30% on the web and app tier. It's probably lesser than that on the intelligence tier because there are less requests going to intelligence compared to the total requests that the application is serving. And then there are some different level of resource utilization here. Now, if I see this from a performance engineering point of view, as a snapshot of the production for certain period, I would say that, okay, no, nothing to worry. This system is going to perform better. But if I view this as a resource optimizer, I start paying attention to the resource usage. So I look at intelligence component. I say, oh, this we have three infra resources, but not all of them are really utilized fully. So can we combine some of them and put components there? And that sort of leads to optimization of the cost. Now, when I present that to the product team, the CTOs, and all that, so they get excited, but at the same time, they're worried about the future. So they would ask that question that, oh, this is fine, but what would be the need for after 6 months? And can we now take some actions which will actually uh, meet the requirements and also reduce costs for that period? So that time we go into the capacity planning kind of mode, use the performance testing techniques where we craft the request in such a way that they represent the expected user load based on the product sort of sales forecast and all that. And then run those tests, maybe on a stage server, and we sort of get this chart too. Now it says that, okay, if you reach that, those levels, web and app tiers may be, uh, so if this particular picture comes in that test, we'll say web and app tiers may be loaded already, they may need to scale, but then the load balancer and auto scaling will take care of that. Whereas the intelligence components, we have custom put days, those, and we have not put them on load balancers because of extra costs that we'll incur. We still looks like our optimization that was done here can still be useful here, although there are a little more requests going there and the load has increased a little bit, but there's still opportunity to do that. So the decision that we took here can continue to work there. And now that becomes the real good information to the team, because then we would have used a technique which also gives them peace of mind until their load reaches a certain level. And then this can be periodically done. That's really the crux of the method.
Thanks, Suhas, for explaining it so well. I think the architecture diagram totally nailed it. Getting a gist about how to utilize performance analysis, capacity planning, and optimizing it in a way that it doesn't just serve the current purpose, but even for future purposes. I think that's the secret sauce. And I hope this has helped you if you are a listener. And if this is a problem that was troubling you, I hope we were able to answer all your questions. If it hasn't, then please feel free to write to us at consulting at harbingergroup.com, and we'll get back to you with our solutions and our recommendations. Also, you could drop us a comment below and we'll try our best to get back to you. And for the others, thank you for listening in, and a special thanks to Suhas as well as Mahesh Kumar for joining us in this Point of View series. Thank you and stay safe.
Thanks, Jomi. It's our pleasure.
Great, thank you.